This is a recording of a presentation made to the Australasian Simulation Congress on the 11th of November 2021. Subject of the presentation is simulation of medical imaging for a new hospital design. Good morning everyone, my name is Rob Brownie. This is what we're going to cover: the modelling team, background of the project, innovation and role of simulation in healthcare, problem and aims, KPIs, data, method, verification and validation, model demo, results, and conclusions. First, the modelling team. We have Mr. Evrim Kilic, Dr. Peter ONeill, and yours truly, Rob Brownie from Inside Acumen. Here is the background to this project. The design challenge for a new hospital is huge. The diagram on the left shows a bunch of that complexity, but certainly not all of it. There's a large number of units, services, resources, pathways, timings, schedules, delays, interconnections, codependencies. But what about future technologies and their impacts? And what is the future demand on this system? Our role is to support moving from the planned system on the left to an effective and efficient operation on the right. In moving from current to future state, how often is policy changed based on pilot programs and evaluation? Pilots that once in action may have unforeseen consequences or that might take multiple years to understand the impacts. So ideally, improve efficiency and productivity via value-based care. What changes can be made to provide better outcomes and improved costs per service? Tools to assist health make better informed decisions. Roadmaps that allow health to deliver better value for clients and patients and visualize the impact of those changes, and support stakeholders with a shared commitment to improvement, being able to future-proof these changes or improvements. In the context of these immense challenges and complexity, let's now discuss innovation and the role for simulation in healthcare. In this slide, we have the real world at the bottom of the slide and a different version, a simulated version of the real world at the top of the slide. In the real world at the bottom half of the slide, what is the best way to introduce a solution to a problem here on the left-hand side? To move directly to a solution can be very risky for time, schedule, resources. So before investing time and resources, it makes sense to mitigate the risks using modeling and simulation and experimentation. So simulation allows this to take place, and this is our forte. Let's now look at the identified problem and our project aims. This is what we needed to do. We needed to test the design of a new hospital to establish a future design. For data, we had current demand for model validation and forecast demand in 31-32 and 2036-37. We needed to build and test the model against future KPIs and test future performance via various scenarios. Now for the KPIs. The KPIs were provided by subject matter experts from within the current system, with emphasis on resource demand measured by utilization and waiting time. To the data, method, and V&V. To summarize the methodology, which is pretty generic by project, get the required data, engage closely with stakeholders, map the process, establish interdependencies, determine assumptions and constraints, build the model, conduct a V&V, review to establish the model is fit for purpose, and once that is done and agreed, forecast the future with reasonable confidence. And here's how that process looks, with modeling and simulation playing a role in the blue area, with the intention to reduce the risk of future failure. For data, we use 3+ years of historical data for model validation. We used forecast demand in 2031-32 and 2036-37. This future demand information was provided from departmental level data. Now we'll look at the imaging system process flow logic. The key parts of the process flows were mapped, and color coding was as follows. The orange represents current base case resources. The pink represents entries, exits, and processes, and the blue proposed scenario tests. At the top of this slide, we can see outpatients and external demand entering the system into reception and waiting areas before going to their services. At the bottom of this slide, we have women, pediatric, and inpatients demand entering the system for holding and waiting areas before going to their services and consuming resources in this system. So the summary here is that the current state is orange plus pink, and future state is orange plus pink plus blue sections. For the technology, we used ExtendSim software to develop the model. For durations modeled, for current state, we used 3 years of historical data, while for future state, we used 10 stacked single-year variations run randomly with a warm-up period of 1 year. Then we averaged the key metrics. The entire future data set was approximately 600,000 rifles over 10 years. The run duration was approximately 30 minutes. And this is a look at ExtendSim. For those of you who haven't seen it, here's a quick look. I describe it as electronic Lego for serious modelers. I've just activated the video here. You can see entities moving through the model. All of these green blocks you can see on the screen, and the other blocks come from libraries that you drag out onto the canvas and connect for your system to make it fit for purpose to model the system you need to model. So at the moment we're highlighting an area where we're able to set attributes of these entities as they enter the model. In that particular case, we are setting color. What's highlighted there is an 85-15 split for pathway. That highlight showed setting of a duration via a random block. The highlighted area shows 2 pathways after a split where we are spending time in activities. There is a merge, there is a split 40-60. And now we've turned animation off to establish some key metrics, and the key metric in this particular demo is the number of exits of the model. In this case, the mean number of exits was 2016.3 and the standard deviation approximately 56. And that is a general model demo of ExtendSim. And here is a part of the canvas of the imaging model in ExtendSim. So from left to right, we can see pediatric, women, inpatients, outpatients, and external, arriving to reception, into waiting area. We also have a holding bay. The other areas are the modalities or services in this particular system. Towards the top, the user can also select a data set from this drop-down menu to run through the model. And here is the imaging model demonstration. So what I've done here is fast forward in the model to 50,000 minutes, which we can see just down the bottom here, bottom of the screen. So it's a fast forward to 50,000 for the demonstration. I've turned animation on so we can see movement of patients in this particular case through the model. Highlighted areas here are the entry points for pediatric, women, inpatients and outpatients through their arrival section to reception, waiting, onto services. Opening up this pediatric area, we are setting a random duration here. As another patient comes through, you'll see the time change for that activity. Opening up patient arrival, we're setting max items in activity of 1 in this case, and a duration of the activity in minutes. Closing that block, opening up reception area. This particular reception area has a resource called receptionist. That highlighted block is a queue for that resource. In this activity, we will consume the resource for that time and release it via that particular resource pool release block. And some metrics for the resource pool, total resources, resources in use, available, and utilization, which is approximately 10% at the moment. Crossing out of that and scrolling down, this is a view that we saw a short time ago in PowerPoint. And we can see just different representation here. It's the same model, just a different representation. And just to make it a little bit clearer, we've used more bitmaps. So you won't get any item flow in this particular view, but we'll get other metrics. And here are some charts showing utilization. I'm now going to turn the animation off so that these utilization charts will build faster in real time. You can see them moving to the right over time. So that's a bit of a demonstration of the imaging model in ExtendSim. Let's now have a look at the results. So for the imaging department current state, this model sought to outline the current state for imaging department. We operated with the existing hospital records to set up the patient flow. We received information on FTE and number of machines assigned to each modality, and we ran the model for 3 years and calculated the utilization. You'll note here that for this particular MRI utilization, we have 162%. Reason for that is that the MRI was allowed to operate beyond business hours in the model. So high utilization means that the MRI was used for large periods of time outside normal business hours. So the normal business hours are the denominator in utilization calculations, and the number of machines in current state are indicated in the parentheses. Now for the future base case, this sought to model 3132 and 2036-37 samples without any scenario tests at this stage. From the previous process flow map, the future base is shown in the inset box at the top right here by pink, orange, and blue sections, that is all the sections. We conferred with the imaging functional group to set the number of machines for future state, and they are identified within the parentheses again. We also implemented processing times based on historical data and made the patients flow accordingly. In this slide, in the blue, we have 2031-32 results for future state, and in green, 2036-37. And in this table, you can see a summary of the utilization results for the future base case. The modeled modalities are in the left-hand column, followed by number of machines, the utilization in 2031-32, the utilization in 36-37, and then the difference between those future periods. And there was an increase in all cases due to future demand being higher, in all cases except for bone density at the bottom here, where the difference was 0%. All right, let's now have a look at some of the scenarios. So this was the first one, so maternal fetal medicine, or MFM. So this is one that the imaging functional group asked us to test. Why? Because MFM demand usually puts pressure on the women's ultrasound resources. So what we did, we modeled a decentralized machine and let patients flow through a different version of the model, allowing specific focus on MFM. We tested the decentralized MFM scenario for both 2031 and 2036-37 samples, and for this instance we used one decentralized machine. The utilization figures we achieved justify decentralizing an MFM resource, both well over 100%. Next, let's look at the pediatric emergency department. So here's PED. Now, the demand here can be unpredictable and place extra pressure on imaging. Through our discussions, we pinpointed the X-ray machines as the resource in highest demand. So we tested the possibility of a dedicated X-ray machine for PED. Both samples showed that a new decentralized resource for X-ray would be well utilized, but demand was not significant. And with only a slight improvement in average processing time, with 21 minutes compared with 24 for the current state, there was no clear justification to have an additional X-ray machine in PED. The final scenario to present is MRI. For the MRI option, according to the current state, the imaging department only uses one MRI machine. We saw in an earlier slide a very high utilization of 162% for the single current MRI machine. Our testing of future state samples with single MRI showed a system even further stressed by higher demand. We can see this here with 3132 single machine and 3637 single machine. Since utilization and average processing time figures were high with a single machine, we modeled the future scenario using an extra MRI machine. That's indicated by these figures here. We have 3132 with 2 machines, and here's 3637 with 2 machines. So 2 machines were observed to reduce the pressure on the system with improved patient experience. The average processing time cut in half. So in conclusion, a decentralized provision of ultrasound services is viable for maternal fetal medicine. A centralized X-ray service is recommended for PED to keep waiting times reasonable. And at least 2 MRI machines are required in the future system. Just a bit more on ED. Our main focus in ED was on X-ray, not ultrasound, not computerized tomography or positron emission tomography. We were not asked to investigate lift reconfiguration, porterage, or space and tech reconfiguration. However, these factors would likely count against any potential business case for decentralization. Now to opportunities. Opportunities for simulation in healthcare. Improve inputs for other models. Inform new design. Reduce risks to testing changes, and reduce risks to operational outcomes. Simulation provides an efficient and cost-effective method for testing possible futures, a better understanding of health systems, and allows lower risk for testing possible futures, and increased agility to undertake further testing. So that's the call to action. This is what we covered. Bit of a recap there of what we covered. And here is some contact information for us at Inside Acumen. Thank you very much for your time.